I'm going to do a few problems. One includes a horizontal compression. Another includes, taking some words and creating an equation out of it and understanding the translation. And the third one is also taking some words and understanding what that translation means. So the first problem here, it's an example, f of x equals 2x minus 1. And it says to apply a horizontal compression of 1/3 to the function. So our function is 2x minus 1. When we apply a horizontal compression, remember, over here we can write what a horizontal compression is. That's f of 1 over b times x. And b in this case is going to be 1/3. So I like to do little side projects over here to really understand, well, can I clean up that fraction at all? We are really doing f of 1 over 1 over 3 of x, which is confusing. So I like to chunk it. F of 1 over 1 over 3 is the same as, well, let's do 1 divided by 1 over 3. We're going to change that or switch that to multiplication and flip the fraction and we'll get 3. So f of 1 over 1 over 3 is just the same as f of 3x. So what that means is everywhere where there's an x value, in here, we're going to replace that with 3x. So f of, we're just going to do it in red maybe, 3x is going to equal 2 times 3x minus 1. Now we just have to clean it up a little bit. I always like to name my new functions, so let's just call it h of x. That's what we're going to do. We're going to do a translation of f of x to create h of x. And that translation is going to be cleaned up. So let's use the distributive method. That's going to be 6x. And then all we have to do is minus 1. So our new function h of x is 6x minus 1. Let's try our next one. It says write an equation for a cubic function with a vertical stretch of 5, and a vertical shift down of 2. So I always like to underline the things in the word problem so I can break it down a little bit. So when I see something that says equation for a cubic function, I immediately think of my parent function. Maybe it's f of x. I name it f of x. I know it's x cubed. I'm going to start with x cubed and just put it down here because I know whatever I'm going to create, maybe my new function we'll call as g of x, I know it's going to have to do with x cubed at some point. So I can break this up into little chunks too. A vertical stretch of 5 looks like 5 times f of x, following the notation for a vertical stretch. So that means that I can basically just multiply my function by 5. And then, because my f of x is x cubed. And then, the next thing I'm going to do is, it says I'm going to shift down 2. Well, I know from my notation that to shift down 2, I just subtract 2 from the overall function. So I know that all I need to do is subtract 2 from this function. And that's how I do it. So this is my final answer. G of x equals 5x cubed minus 2. The last example we can try is this one. It says write an equation for a square root function with the horizontal translation right 6. So again, let's break it down. First of all, it says write an equation. So we know we're going to have an equal sign down here. And we also know that we're creating a new function. So why don't we call this new function m of x. Okay, so I'm going to write on the left-hand side my new function name. And I'm looking for the square root function. Well, that's telling me that my parent function that I'm going to use is going to be the square root of x. So I can even write the square root of x down in my function just to get me started. And then the next thing it says is do a horizontal translation, write 6. Well, we know this is going to be f of x, and it's going to be to the right, means I'm subtracting h. So my h equals 6. So I'm going to be subtracting 6 from my x value of my function. Now this is where you got to be super duper careful. Everywhere where there's an x, we're going to replace it with x minus 6. So m of and that's in the f of x function. So this is going to be the square root of, and anywhere where there's an x, I'm going to subtract 6. Again, m of x is my new function. My old function was f of x. So this is where I take f of x and I am substituting in x minus 6 everywhere where I see the x value. And this is what is going to be my m of x. So that is how you solve that problem as well.